So, hi everyone, welcome to our panel on space architecture. We are tremendously excited to have you here on board. And before kicking off this discussion, I'd love to thank our amazing panel for coming here and then expressing this genuine interest to participate in this conversation and promote this field, this nascent field of space architecture. And also, I'd like to thank Koshin Terrell for helping hosting this panel on their Zoom. I'm Anastasia Prosina, moderator of this panel today. I'm a space architect, CEO, and founder at Stellar Amenities. We pursue the mission of designing super functional and comfortable places in small spaces from Earth to Mars and everywhere in between. And so in next slide, I'm gonna go to next slide. Yeah. And we are excited to have you here on board, as I said. And we see that there's so many people around the world joining us. There's already 124 people, which is extremely surprising and amazing, like that this panel got a lot of attention. In an effort to make this panel much more interactive, we invite you to respond to the 2 questions in the poll you can see in the screen in a few seconds. We will disclose these responses in the end of the session, so you will later know who is actually joined this session, like how many scientists, how many filmmakers, how many artists and art space engineers joined this session. And I just want to add some thoughts on space exploration. Space travel is the most exciting and challenging adventure that humanity has ever taken. And human endeavors in space abound, and more are on the way, establishing a permanent presence on the moon by 2024, building the moon orbiting station Gateway, a few private space stations orbiting the Earth, and eventually colonizing Mars. As humanity pushes the boundaries of space exploration, the human aspect of the living in space is often neglected, leaving the space exploration a significant danger both physically and mentally. Going to space is risky. The planet environment is naturally hostile to humans. And the reason of hosting this panel is to address these challenges of human access to space and reflect how we're actually going to live in space, whether it's going to reflect the sci-fi production that we see, or it's going to be somewhat different. So our agenda is going to be, as you see on the screen, we're going to start from panel presentations, what we are doing, like as a space architects, what we are doing, what we are driving by, and then we're going to open our discussion on space structure, sci-fi versus reality. As I mentioned before, how sci-fi depiction is different than what we're going to see in space, and actually what we're going to see in just a few years. And then next topic is space habitation and human-centered design. We were going to talk about how space architect is different from an engineer, and then how design practice it's unleashing the potential space architecture. And then the topic number 3, it's life in space and life in quarantine. What kind of learnings we can have, we can have from space architecture, and how we can apply for the current situation of the COVID outbreak. And then we're gonna finish with Q&A. And then from this moment, you can ask any questions, as Erin said, in the Q&A tab. So all the questions will be sorted, and then we will pick 2 or 3 questions that are more interesting, the most interesting questions, and then we're going to address these questions to the panel. So yeah, let me introduce our panel. Melodie Yashar, co-founder at Space Exploration Architecture. Melodie focuses on relationship with advanced software and hardware systems, in addition to material engineering for the space sector. Next is Erin MacLean, senior user experience designer at Blue Origin. Erin explores social technological futures of life and work in outer space. And Corey Johnson, who kicks off our panel presentation today. Yeah, Corey is an architect at Cushing Terrell. Corey now casts his eyes up to the stars and asks the question, how will we create built environments in outer space that are safe, warm, hospitable, sustainable, and inspiring for space pioneers? Corey combines his passion for practicing architecture, Cushing Terrell, his expertise designing learning experiences from the next generation of explorers, and his love of amateur astronomy to ponder architecture in space. From Jetsons to Jedis, the future is around the corner. Please welcome Corey to the virtual stage.
Yeah, thank you. Hey, and before I get started here, I noticed we've got about 12% of you that have taken our poll. We'd like to hear from a greater percentage of the audience. So take time to answer those, and we'll be ending the poll here in about 5 minutes or so. So thank you. And greetings. Yes, I am an architect that focuses on school and university designs, also a space nut. Why do I focus on education design? Well, to be quite honest, I was a pretty lousy student, at least until the 6th grade. And this is when my family's trip to Disneyland, the release of Star Wars, yes, the original one, giving up my age there, and school drafting class elective all coincided around the same time. And I saw a pathway to take my doodling and imagination into the career of architecture. Specifically, the design of innovative schools and creative learning environments that connect with the diversity of all learners. And when you really stop to think about it, Earth-based schools and campuses really have all the components needed in space colonies, right? We got labs and dorms, social halls, social centers, fitness gyms, all the ingredients needed for a healthy body, mind, and soul. So I personally invest my time and talents in our youth, in mentoring our young workforce. My grandson Calvin was just born in January of 2020. He's that very cute baby there in the lower right-hand corner. And I can't imagine what Calvin is going to see in his lifetime and the experiences, but I'm pretty darn excited about it. Next slide.
Yeah. 1 second.
Yeah. All right. So after observing interviews with astronauts that have ventured to outer space, they all seem to have one thing in common, and that's a newfound appreciation for our own planet Earth. It's truly amazing to realize the spin-off technologies that came from those 1960 Apollo missions, isn't it? And how they are utilized today. Specifically in architecture, products such as energy-efficient LED lighting and solar panels, fabric structures, fireproofing sprays, and thermal insulation have greatly improved our field. It is my hope that our newfound quest in colonizing space will spark yet another wave of amazing advancements, such as improved health and safety systems. We could really use that right now. Better space utilization and flexibility, extreme sustainability, new ways to harness and conserve energy, 3D printing and terraforming construction techniques. I believe our current focus on designing space architecture will not only benefit our Mars colonies, it will revolutionize our designs right here on planet Earth. Go ahead to the next. Mm-hmm. I really find it fascinating and inspiring on how science fiction and imagination has influenced science, architecture, engineering, and vice versa. Let's look at the idea of cloud cities. Now, I'm not quite sure why they're needed, whether to protect us from the surface below or give us a better view from above. There's been quite a conversation as to which came first, the Jetsons Orbit City or Seattle Space Needle. However, does it matter? I think what really matters is that both the thoughts of our sci-fi dreamers and the creation of our innovative designers strongly influence one another. This sharing and building upon thoughts and ideas can inspire and improve our future designs. Isn't it fun to reflect on Star Trek gadgets that now exist today, you know, such as cell phones, universal translators, tasers? But I also find it equally interesting that the show's creator, Eugene Roddenberry, was a former Air Force pilot who brought with him countless prior experiences. Let's go on to the next topic. The use and concept of orbiting space stations for our colony homes, travel, and exploration have been conceived since we first turned to outer space. Whether it was early NASA concepts or sci-fi visions, we have understood just how important and dependent we are on gravitational needs. Using spinach centrifugal principles, could we create our own artificial gravity? After exploring the logistics, science, size, and cost of developing these spinning stations, this concept has yet to be realized. Even our International Space Station didn't incorporate it. However, for the past 20 years that it's been orbiting, the astronauts have been researching ways on how to keep our bodies healthy for longer term travel and living. And gravity is just one of the many, many important elements. These structures need sustainable energy and supplies, redundancies, and repair capabilities, and protection against harmful radiation and space debris, to name a few. Still, with all that aside, wasn't it fun to see the surprise ending of Interstellar? Warning, spoiler alert. That large spinning O'Neill cylinder, called Cooper Station, it attempted to take all the comforts of home with us. Plants, animals, agriculture, and yes, even a baseball diamond up into outer space with us. Next. The dome, a mini biosphere, is a widely used architectural element when it comes to space colony concepts. Does it have to be a dome shape? Not really, but the dome does have some advantages. The dome has been used throughout ancient history, but the architect Buckminster Fuller really inspired its use in modern times. That Biosphere 2 research facility really took the concept and tested it. And what did they find out? Well, it's pretty darn difficult to get a closed system balanced and fully sustainable, even here on Earth. We also found out just how important human sociology and psychology and interactions are in the equation, right? So when we think about the sphere, we really need to consider both the protection from hostile exterior environments and interior environments. If the planet doesn't have a life-sustaining atmosphere, which we've only found this one so far, then some form of a biosphere is going to be necessary. And these environments need to sustain a healthy and prosperous life, use planetary resources, net zero strategies, and living with less.
Thank you, Corey. It was inspiring. Our next panelist is Erin MacLean. Erin is a cross-disciplinary designer, engineer, and strategist passionate about solving big problems that impact humans and extreme environments. Her recent work has focused on objects, environments, and systems that improve productivity and safety of human spaceflight activities. She is currently a senior user experience designer at Blue Origin, building human-centered design capability at the company. Erin has experience designing for Walt Disney Parks and Resorts, Amazon, MIT Media Lab, and Nordstrom, and AT&T. Welcome, Erin, to the virtual stage.
Thank you so much for that introduction. Could you skip to the next slide?
Sure.
Thanks. Hello, everybody. I'm Erin. I'm a human-centered designer and engineer, which is an intersection of human factors engineering and user experience design, psychology, anthropology, throw in a little bit of geology for fun. And my research focus has been on humans operating in extreme environments. I've looked at backcountry wilderness medicine, deep sea commercial divers, and more recently, humans operating on the moon, Mars, and the space in between. I have to give a quick disclaimer before I jump into all my stuff. Nothing I'm going to show is going to be stuff Blue Origin's doing. None of my opinions represent Blue Origin opinions, and I can't answer any questions about Blue. So I'll just talk about the cool space stuff I was doing before I started at Blue. Next slide, please. So I approach design problems from a systems thinking perspective, and I think about the complex systems that humans go through their end-to-end journey, essentially. And when we think about this in terms of space, let's take the most complex future mission we have out there, which is sending people to Mars. We don't just have to design for how people will live on Mars, but we have to think about the pre-launch activities and launch and transit to a space station, potentially some time on the lunar surface, transit through deep space, and then living on the surface of Mars, and then they have to come all the way back again. And we have to model all these discrete touch points along the way. And what's really interesting about that is we functionally know how the human body changes in these different environments. But beyond that, what's more important is how we're going to psychologically change under duress, long-term cohabitation and working with people, the philosophical change that happens when we can't see Earth from the night sky on Mars even. And we have to build objects, systems, and environments that adapt to these changing human needs. And so I've looked at things often I've specifically focused on the part of the journey of field excursions, so EVA field excursions, and how that will look on the lunar surface and on the Martian surface, and how that affects the rovers we design, the habitats we design, the tools and technology for them, because this is going to be our primary activity on other planets. And so we have to design to afford for that activity and that human experience of having to be geologists. Next slide, please. And so while sci-fi is a huge component, I also science fiction is a huge component. I want to bring in this concept of design fiction, which might also be called speculative design. And this looks at not what the human race will be like in 200 years or many years ago in a galaxy far, far away, but where are we going in the next 2 to 5 years? How is our technology trending? And where can we meet it with solutions to the complex human problems we'll face in space? And I think one advantage of being in the space industry is we do have the affordance of longer timelines versus in the tech industry, which is continuously iterating and continuously releasing, is we do have to train people on Earth first. We do have to wait to have a vehicle to launch something on. So design fiction is actually a really good exercise. Next slide. And a great affordance of design fiction is it takes the storytelling aspect from science fiction and it imagines realistic scenarios that will probably be happening in the near future, and we can do low-cost experimentation of space activities within analog contexts from it. And so, next slide. Thank you. So before coming to Blue, I was in graduate school. I was working on creating the interaction design guidelines for the next generation spacesuit, the XEMU, for the augmented reality interface that is spec'd to be in the spacesuit. And I got to test that down at JSC. But in developing these interaction design guidelines through a human-centered design approach, there were larger design implications for humans in the context of deep space versus the moon versus Mars that affect not just how a tech interface looks, but the environments we design for people. Next slide. I think first order impact is gravity. So gravity on the moon is 17% of that of Earth's gravity, and we use a significant portion of our working memory actually just staying balanced. And that has huge implications for how we're going to design environments where we have to actually work at staying upright. But when we're on Mars, which is 33% of Earth's gravity, we're not actually spending significant amounts of our working memory staying balanced. We feel like we can run a marathon. We actually gravity becomes a superpower for us. Next slide. I've done work with also just how colors in the environment should look. When you have different solar radiances due to different atmospheres, we have a pretty well functionalized solarized color palette for Earth, but it's going to look different on Mars and the moon. Next slide. And then also thinking about how we're going to find our way on the moon and on Mars when we can't pull up Google Maps to go to our field sites. We've geohashed the moon. but obviously we don't have streets or roads there. And so how are we going to build these early paths to where we need to go? And it's actually going to be human created. It's going to be created from not from like an urban planning perspective, but from desire lines, from the easiest way to get there with the tools and technology that we have. And so creating digital markers to build these early paths, and that could have longer term implications for urban planning on the moon. And then next slide. And also just thinking about, at the core of everything I do is thinking about how to improve productivity, safety, and job satisfaction for our future astronauts, because this isn't the Apollo mission where they have a limited amount of time to collect hundreds of samples, where you have to think about long-term human habitation in these spaces and how can we create touch points that support these people doing their work. And so I've looked at stuff such as a voice user interface that can ethically be listening at all times and be an extension of the crew member. So that's just a few things I've thought of, and I'm going to hand the ball off to Melodie.
Yeah, our next panelist is Melodie Yashar. Melodie is a designer, technologist, and researcher. Melodie's work operates as an intersection of experimental, narrative, and intersection design practices. She prides herself in being a conceptual designer capable of developing a project from its schematic phases to the final realization and execution. Having come from an interdisciplinary background, Melodie appreciates those who see research and design as a confluence of different fields, allowing problem solving to become a more thoroughly collaborative exercise. And then, yeah, welcome Melodie to our stage.
Thank you, Anastasia. Thank you, everybody, for participating and for joining us in this webinar. And thank you, Anastasia, for coordinating all of this despite cancellation of South by Southwest. So hi, my name is Melodie Yashar. I'm a co-founder of Space Exploration Architecture. We are a startup. I like to refer to Space Exploration Architecture, which is also goes by Search Plus, as an applied research practice. Next slide, please.
Mm-hmm. 1 second.
Oh, okay, great. And so these are some of the space architecture projects that Search Plus Space Exploration Architecture has developed since our inception in 2015. We incorporated as a direct result of winning NASA's Phase 1 Centennial Challenge for a 3D printed habitat on Mars. So today I'll tell you a little bit about our work in the Centennial Challenge program as well as outside of it. Next slide, please. Our mission statement and our goal in the work that we do is to conceive, investigate, and produce innovative human-centered designs which enable human beings to not only live, but to thrive in space environments beyond Earth. I'm going to go fast. I have a lot to go through here. Two foundational concepts, and I apologize that these happen to be the more technical slides that I have for you, but these are important and they're instrumental in the way that I think about the work that I do in Search and outside of it, but also they're extremely useful and instrumental in how we think about space architecture and its phase development from where we are today, which is basically with the ISS and with space station as it is right now, to where we will eventually be in living and working on the surface of Mars and the moon. So this is not my slide. This is a slide developed by Scott Howe at JPL. And here he's basically putting forward these three classes of space architecture. The first, pre-integrated hard shell modules, the second, prefabricated and surface assembled, and the third being ISRU derived with Earth integrated components. So when I discuss in any work that discusses autonomous construction of 3D printed habitats on the surface of Mars, we are only referring to class 3 space architecture. So we have a ways to go before we arrive at that reality. Next slide, please. In 2016, United Technology Aerospace Systems, UTAS, which is now Collins, approached Search Plus asking us to come up with a concept for integration of their Eclipse pallet hardware within what will eventually be inflatable habitat systems as part of Gateway in the Next Step program. So at the core of this idea is they were asking us to investigate the relationship between the crew member and the hardware that they would actually be interfacing with aboard the vehicle, the functional grouping of that hardware, which would become egless, or that is egless, and the relationship of that hardware to the vehicle and to the ship or the habitat. So within any variety of space architecture, the vehicle and environmental system, the hardware and the software systems aboard the vehicle, and the front-facing human interface are always going to be in a constant feedback loop. And this is a really instrumental concept for the work that I do, both within search as well as outside of it, because it drives to the core of human systems integration. Next slide, please. So what does that actually mean? When UTIS approached us with this problem for the Next Step program, they were basically asking us to address how this highly technical hardware that you see on the left, this functional grouping of egless palettes, could eventually be translated into a space habitat or into an environment that would be more like what you see on the right. Or next slide, please. This is another iteration from the same project. And next slide, please. Or this, another iteration of the same project. Next slide. So at the core of this project, and at the core of every project that Search does, I think you have to advance one more time. At the core of this project, and the core of every project that we engage, both in competitions or whether they be contract jobs or whatever, we are looking to synthesize engineering constraints with human factors driven design innovation. This is really at the core of what we strive to do. Next slide, please. So now I'll go into a little bit of our work that we did for NASA's Centennial Challenge for 3D printed habitat on Mars. Next slide, please. On the left, you'll see that was when we won phase 1 of the design challenge. On the right, that's when we won phase 3 of the design challenge. Essentially, we've won both of NASA's design solicitations for 3D printed habitats. Next slide, please. So this was a multi-phase competition which asked the general public to come up with concepts of operation for autonomously constructed 3D printed surface habitats on Mars. I'll tell you a little bit about the work that we did in phase 1 and phase 3. Mars Icehouse was the first prize winner in the phase 1 competition. Mars Icehouse introduces, next slide, please. Mars Icehouse introduces inflatable ETFE membrane with a 3D printed ice shell on the inside, as well as a vertically oriented lander from which all mechanical systems and nucleus are housed. Next slide, please. Here's a view of the outside of Mars Icehouse. So why did we choose water ice as a building construction material? This was a fairly deliberate choice on our part, because we know now that water ice is superior at shielding against radiation than regolith. So this was a clear choice for us. In any sustainable mission to Mars, we recognize that ISRU mining of water ice is going to be absolutely critical for a sustainable mission over the course of a year or more. Next slide, please. We were also interested in the potential for water ice to introduce translucency so that the astronauts could maintain a connection to their broader landscape over the course of their mission. We were able to validate and verify this through a couple of, I guess you could say, tabletop experiments that were done at Lamont University, where we could establish whether the ice grain in filled and frozen Tedlar bag could actually be translucent enough to achieve the kind of vision windows that we were projecting in this more speculative proposal. This is a view of the intermediate containment zone that we designed in Mars Icehouse. On the right, you see the IBO, which is the 3D printing ice bot, which would be printing and moving up and around the habitat to create the ice shell. Next slide, please. This is a view of the exterior of Icehouse. And we were very fortunately able to be connected with a PI at NASA Langley in the Game Changing Development Program who was interested in the potential of an ice habitat to introduce superior radiation shielding for the crew. And together we came up with the Mars Ice Home concept, which instead of being 3D printed was a filled and frozen inflatable system for for an ice habitat. Next slide, please. Here's a view of ice home on at night. In this case, we introduced the, next slide, please. We spent some time going into the material system and the bladder and restraint material layers that would be required for this habitat system to actually deploy. We didn't introduce any kind of functional programming on the inside and left it sort of empty, I guess you could say, so that any kind of programming could eventually be applied. This concept was later addressed within the Big Ideas Challenge that was also coordinated by NASA Langley. Next slide, please. Okay, and now I'm going to tell you a little bit about the phase 3 winner of the 3D printed habitat competition. Mars X House was our proposal for a 3D printed habitat. That the material system that we chose, next slide please, was a sulfur-based regolith cement with a high-density polyethylene inner layer. This is getting to the heart of some of the design drivers and principles that were integral in coming up with the concept of operations for Mars X House. So we were, and it's the same with any, I guess, surface habitat proposal that we've worked on in the past. We were synthesizing Mars environmental drivers, constructability and mission drivers, as well as human factors components that would enable us to augment our proposal for this surface habitat. Next slide, please. This is a view of X House from the exterior. Next slide, please. A rover approaching X House, you'll notice that we have a egress tunnel that wraps around the habitat itself. Next slide, please. This is just to give you a sense of some of the visualization work that we had done over the course of the competition. This is a view of X House from at night. Next slide. A view of the interior where you'll notice the high density polyethylene is the material that the astronauts would actually be interfacing with. There's this, we have this fear of perchlorates within regolith being toxic to astronauts, so we didn't want to risk at this stage not having a validated technology for those to be eliminated. We wanted to be sure that the high density polyethylene, which has some really, which is a really high technology readiness level material for 3D printing, would actually be what maintains the pressure on the inside of this habitat. Next slide, please. This is showing the wardroom at the very top level of X House. Next slide. And here we got into some of the details of the material system and the composite wall of the habitat itself. So part of the challenge in coming up with this concept of operations for autonomous construction is that we not only have to think about how these materials would derive locally and indigenously to achieve a fully operational ISRU program for 3D printing, but also we have to come up with an appropriate construction sequence for that to happen. So in this case, you'll notice the high density polyethylene is on the interior. We have basalt reinforced fiber, basalt fiber reinforcement within the concrete, as well as a regolith shell and the regolith shell on the outside. Next slide, please. Here we're showing the construction sequencing that we came up with. So the foundation regolith, high density polyethylene on the interior, and the concrete shell on the outside. Next slide. And finally, this is a simulation of the construction sequence of the entire habitat, where you'll notice that there is a deployable mechanical core that is housing all ECLIS and mechanical systems. We simulated the lift that would be required for the 3D printer to actually print up and around the habitat as it's being constructed. We simulated how the vision windows would be installed and at what point. And yeah, next slide. Thank you. If any of this interests you, I would be happy to answer any questions both here and afterwards. Feel free to reach out.
Thank you, Melodie, so much. So I'm going to be the last presenter. So my name is Anastasia Prosina. I'm the award-winning practitioner in space architecture, the nascent field of helping people thrive in small spaces in outer space. I'm the founder and CEO of Stellar Amenities, where we design super functional and comfortable places from Earth to Mars and everywhere in between. And my journey as a space architect started when I discovered the works of the Soviet space architect Galina Balashova, and I was really surprised that the coordinates that she's been working on her projects, and the notion that the different colored zones allow astronauts and cosmonauts in a state of weightlessness to easily determine where the ceiling and the floor are, and then the color palettes, which is really excited me. And then I became a journey in 2018, pretty much like 2 years ago. We entered a Marstopia competition with my friends, and then we won the People's Choice Prize, which was really surprising, amazing competition. And yeah, we utilized the principle of origami as the one of the most efficient ways to store habitat structure. And then as a grad thesis in my architecture school, I've been working in the settlement system on Mars, basically figuring out like where resources are located, and then how we actually going to expand our presence on Mars, like step by step, and then relying basically was about like how well the transportation going to be developed, what kind of transportation we're going to use, and how far the settlement points going to be from each other. Oh, and then the next project I done was I moved to Houston, and then I was working in with a company called Excalibur Mass. It owns a flew Soviet space station, Soviet space station, and then the owner approached our Center of Space Architecture in Houston, asking whether we could come up with solution of interior design for dual use space tourists and space researcher, which is astronauts, right? So it was a pretty much amazing experience. And then I've been working in the Martian analog habitat in Iceland, commissioned by Mars Society. I've been working with the fourth planet logistics. So it's a deployable habitat. And also last year, I've been honored to join MIT Media Lab Space Exploration Initiative to come up with a lightweight and deployable solution for the interior of the Tesseract space station. And the last project that we are I'm working right now is deployable chair, which accommodates sitting and leaning working positions, thus diversifying the experience and break up the boredom of being in an enclosed small habitat. Basically, like when we're talking about space exploration, the weight it actually drives a lot. Like, the more you can have payload, the better. Right? The much more payload you have, the better. And then, like, I researched on like what kind of furniture comes with space habitats. Like I'm talking about Martian and lunar habitats, and then I discovered that there's not really solutions for for furniture that could be really lightweight and thus decrease the amount of money we're going to spend on our adventures. And so we designed this cool chair with extremely lightweight and advanced materials you can see on the slide, and utilizing the principle of integrity. And we also minimalized the amount of materials we used, and the plus-shaped back of the seat makes the comfortable backwards of sideways sitting. So it's actually adapts on the position of crew member. And then this chair takes minimal volume when stored, which is really important because like in a small habitat, you don't really have a lot of space, right? And as I mentioned, it has these two modes of leaning and sitting positions, which I'm going to talk later. And also this chair has this weird shape on the seat, which is actually an invasive way of keeping your muscle kind of exercised. So you standing and sitting exercise and being exercised in the chair. So this is a consequence of deployment. I see it takes really a bit of space. And so it's me. I didn't find any other figures to put, so I just took a picture of myself and then sat in the Martian habitat. So here, as you can see, it's kind of a normal sitting position with a bit of inclination, because like if you remember, Martian gravity is a third of our Earth gravity. So we have this theory of that the the posture of a human going to be much open than we have on Earth, and then the sitting position is going to be a bit different. So here's like standing, actually leaning position. So it's actually a way when you have this really fast tasks or mission control calls. And then it's how these chairs accommodate the dining experiences. And now, yeah, now finally we are coming to the session on discussion session. And I want to start from what I think about it. So as we mentioned in our agenda, we are curious like how actual habitation, space habitation gonna look like in the near future, and whether the what we see in sci-fi gonna affect this future. And I'd love to ask this question to Corey. Like Corey, how do you think those structures and vehicles that we've seen in sci-fi fiction movies bear any resemblance to what it's needed to survive in challenging and complicated and hostile environment?
Yeah, well, I'll keep this answer brief. I think some do and some don't. But to our sci-fi friends out there, please keep this imagination and creativity coming. I'm finally getting around to listening to an audiobook, 2312, and it's always exciting to explore new thoughts. You know, look, colonizing Mercury with a orbiting shading sail and a city on tracks that follows the sun. How fun is that? And fellow panelists, you know, practically what you're working on, I'm blown away with what you've shared. We've had a few prep sessions, but this is my first time seeing your full content of work. Amazing. You seem to be doing a good balance of both function and beauty. And I'd say, you know, I haven't spent any time in the ISS, but I think after 20 years, maybe it's time for a remodel. Implementing some of these ideas. But, you know, ultimately our designs must really foster a healthy and comfortable quality of life. And these sharing of thoughts and ideas is key to our best architectural space design solutions. So.
Yeah, I totally agree with you, Corey. Like the way we design for like the imagination. I mean, the sci-fi depiction is extremely important. It's I guess not. I guess it's actually drives you know, invention of the future. So as you see in the slide right now, like it's the first AI we've ever seen in the movie, and now we have Alexa in almost every house, right? And then we have this Simon robot on the ISS helping astronauts to deliver their tasks and maybe some boring tasks, so the astronauts can perform much more creative tasks. And you know, like in Space Odyssey, we saw the very first tablet. And I heard that people think that Kubrick invented Apple, which is not really true. Kubrick invented tablets and many other things, but like Apple, it has one of the products and it's tablet, right? So we can call it, you know, that we can say that Kubrick invented iPad. And you know, 3D printing, which is like you might heard of it. Like there's a company called Made in Space that they experimenting with 3D printing on the International Space Station. And that's really exciting, you know, like thinking about like in the last century, almost like 40 years ago when all these movies came out. It was really exciting to think about like how we're gonna live. And back to that time, I feel like people, they thought that we actually gonna live in an orbital city in like maybe 2000, right? 2010, something like that. Because we saw the rapid change of space exploration. We've been doing rapid things. And people had this imagination about that. So what do you think, Erin?
Yeah, if I could just jump in real quick, I would say that looking at the body of sci-fi work and how it's changed, I'd say especially more recently, we see a lot of science fiction that looks at utopianism and dystopianism. And that's where we get these either these totally run down environments or these all white environments. And I almost want to, and I saw this in the chat too, and I want to quickly just touch upon the all white environment thing that we see in a lot of sci-fi. This is almost, there's this design theory about the application of things. Apple is all white, chrome, smooth surfaces, and really that's an opiate towards the everyday existence of living. And we see that with people looking at utopias and trying to create an opiate against all of the complex problems we face in humanity. But when we look at sci-fi series that actually embrace a middle road, they understand that humans are complex creatures and we're going to bring that complexity into space. Then I start to see designs within these sci-fi series that look a bit more realistic for what we're going to have. If for anybody who's watching Star Trek Picard right now, his office on the spaceship is just a holodeck office of his office at his winery in France. And I think that speaks to the fact that we are going to bring elements of home into space.
Yeah, that's a really good point. Yeah, I feel like you can move on to the next question. The next topic is like space habitation and human-centered design. And here we wanted to cover and think about how, you know, space architect is different from an engineer. It's like majority of people that when I'm saying that I'm a space architect, majority of people think that I'm an engineer trying to solve trying to work as in engineering problems. And but for the past 50 years, space habitation has been purely a system engineering problem, right? And just recently, designers began to appear in this stage. And Erin, I'd love to ask this question: how's design thinking critical for successful practice in space architecture for you?
Yeah, and I'll probably throw this to Melodie also after I answer it, because I'd love to hear her opinion.
Sure.
I think I'm going to broadly speak towards design thinking applied to all the objects, systems, and environments we're going to put into space. You touched upon it earlier that this was a systems engineering problem. We could well functionalize how the human body would operate under different conditions. But now we're thinking about how do we have people exist long-term in space, and we're not just trying to hit the bottom of Maslow's hierarchy of needs, which is survival, food, shelter, but the actual self-actualization that we will have in space, the psychological component about it as well. And so we have to actually concept using human-centered design methodologies earlier on so we can identify these bigger risks. The top 3 risks to human life in space, first is cosmic radiation, which is more of an engineering problem and also a legal problem. But after that, it's intercrew personal behavior and personal mental health. And that's when STEM, science, technology, engineering, and math, expands out into STEAM, art and design. So I think we actually need more multidisciplinary people approaching these problems. We need to be teaching our engineers ethics and design. We need to be teaching our artists and designers more human factors and more engineering concepts so that we can cross-collaborate and build really good stuff. And I want to throw it over to Melodie to hear her answer about it. Not to put you on the spot or anything. I think you're still on mute.
Thank you. Thanks, Erin. No, that's totally fine. I think that historically, systems engineering workflows have been extremely and remain extremely risk adverse, and for that reason have been sort of slow to adopt to the popularity of design thinking and the potential that it can bring to actually introduce efficient innovation in manufacturing processes, but also in any kind of engineering, really. I think that that's slowly changing. I think that the benefits of multidisciplinary design thinking and collaboration are slowly becoming more apparent, particularly as the private sector is getting more and more active and involved in space development and landing and establishing a permanent base on the moon. And I totally agree with you, Erin, that an international host of actors ranging from space development to culture and ethics to psychology and human factors and I mean everything really that would have to contribute to a vision of a sustainable life on another planet. It will be really, really essential to have an interdisciplinary, multidisciplinary group of individuals who will have equal stakes in establishing what that vision of a different life will be.
Yeah, thank you, Melody. Also, I would add that you know, like studying space architecture, like in you know, there's just a few places where you can study space architecture. There's not actually you know, good place to study space architecture. It's just extremely emerging field, and I feel like we should also emphasize that space architecture has a lot of applications on Earth. For example, it might not really be obvious, but like when you design for space, you design for, you know, extremely small environment, try to think about multi-functionality, try to think about like how human being gonna feel like inside, right? And then I can see that, you know, in our current living situation where we are all in isolation, you know, these lessons from architecture could be used widely on application on our daily use, right? And then also, like, besides this situation that we are currently right now, you know, like the places that are overpopulated, like Asia and like places even like in downtown of United States, the apartments are extremely small. So, you know, the lessons we learned right, from architecture could be also applied here. And then also tiny houses. I heard that there's some, I mean, tiny house movement became extremely popular last days. And then there are some really unique solutions for like new models of tourism, like capsule hotels. You know, it keeps the price down and also provides all the necessities you want. And then also the multi-functionality of space architecture could be applied to office places. Like, for example, you know, when you wanted to host a meeting, you have like a certain number of attendees, and then you wanted to change the space, so you can easily to turn one place to another.
To riff off of that just really quickly,
yeah,
architecture and design embed certain narratives in what they create. When you look at tiny house design, that speaks to a certain way of living and coexisting with each other. And I think these narratives are really important for the work we're doing today as designers, as architects, what we're going to embed into the future of space architecture, space technology, space objects, is a certain way of living and working. And so I often think about inclusive space futures. Is there's a lot of constraints that mean that there's only what, like 500 people who have been or are in training to be astronauts right now. That's a very small population. It's a very specific type of person. It's much more diverse than it was 50 years ago, but it's still a very specific type of person. What do how would people with certain disabilities operate in space? People from different cultures that don't usually participate in the narrative today, and how do we embed affordances into our designs so that we can open up that scope of participation as well? And I think that's something that we can do really well as architects and designers.
good. Yeah, good point. And then next, we're going to discuss on you know, the current crisis, so the COVID-19, and how we actually can thrive in isolation during these hard times. Because I've seen that like it's really hard to people to come up with, you know, maybe some entertainment, maybe, you know, it's extremely hard for human being to be stuck in one place.
So I'll throw a question at you then to kick this off, which is, are there learnings we can take from space architecture in order to apply to our current shelter-in-place orders?
Yeah, you know, like I've been experimenting with my own apartment, like maybe for last few months, kind of preparing. I mean, I didn't know about that is gonna happen, but and I've been experimenting on different solutions, and I can say that, you know, the critical learning from space architecture, which could be applied to the current situation, is integrity of spacecraft systems, which makes its own biosphere. And I'd love to imagine this. I would love you to imagine this. The experience you have standing on the shore, the experience you have sitting under the tree in a hot day in the park, and cold day in the desert. You go out and read a book in these different places, and in every places it is extremely different experience, right? It enriches your experiences of what you are reading and your physical well-being. So when you break down all these environments that create these experiences for us, it boils out to just five things, to changes in five things. First, it's the changes in light. Second, changes in radiation. And then changes in temperature, changes in wind, and changes in humidity. And those things can be created in a home using heat lamps. For example, heat lamps allow you to feel cool air on your skin while also being heated from the light. And it's a totally different experience from something being heated by the air around you. Imagine this difference between standing under the sun and feeling the warmth of the light against the cool breeze around you, and versus being just in a warm room like we are right now. And next thing is temperature, which is obviously there are heaters for, so you don't really change, you can't really do something about it. And then changes from humidity. Humidity come from humidifier, which you also can add essential oils to it, and then kind of diversify your experience of, you know, smelling. And then changes in the breeze, which come from fan. And then so for example, and the next feature is air, which you know, the problem of air is you can't really produce a lot of air in isolated space. I mean, if you're not opening any windows, right, there's going to be a problem of shortage of air. And there's still many household cleaners and chemicals that we are using every day. They contribute chemical gases to the air around us when we live in isolation. You might not getting good air then. And so there are a list of plants that NASA determined they are the best for the naturally purifying and destroying these chemicals, and also as well as producing oxygen. And they help us to create the environment and additional visual stimuli, as you see in the picture right now. And remember, you know, as we live in this progressive time, we have all this smart home assistant that you actually can automate all this light environments, you know, color, temperature. So for example, if you don't have a big window in your apartment or house and you just shortage of light, you can use artificial light and that imitates the, you know, sunset and sunlight, sunset and sunrise. And so what I'm saying is, you can be in one room for many months, even for years. Like say you're gonna to be the first man on Mars, or even the second or third. So it's gonna be a real long expedition, and so you can travel from one place to another without even leaving your room, right? Because you have these different experiences set up, and then it can transfer from one to another. Yeah, this is just my thoughts, and I've been experimenting on that, and it feels really good. I haven't been leaving my place for a long time.
And I couldn't agree with all your points anymore. I say thank goodness for technology.
Yeah.
Staying connected with our friends, family, colleagues, is so important. And then, to me, this is, that good air quality, that hygiene, in order to mitigate this, the harm of viruses or bacteria to the system. My goodness, if that's important here, just imagine how vitally important that is for space travel or colonies to take that into account. So, my hope here is that we use this experience to promote our design advancements to improve not only space architecture, but our earthly homes and schools and meeting places and everything in between.
That's right. And I mean, this topic, like when you say we are designing for space exploration, it kind of sounds really kind of far away. It's out of here. And I'm really glad to see the practical tips and practical solutions that we can give from our practice and actually affect the lives of the people. And I'd love to turn to our Q&A session, but prior to that, I want to announce our results of the poll. So that's funny is that almost 50% of our attendees today are designers, engineers, and architects, which is really exciting because you are the guys who are gonna, make a change and go ahead and design space habitats, right? And then scientists and researchers at 24%, which is like really important to have somebody who keep you, out of imagination, kind of keeping strict on your imagination and letting your dreams come true. And then a bit less, we have academia, and we have sci-fi, space industry professionals. And guys, that's really exciting to have you here. That was an amazing conversation, and I like the questions that you asked. We're gonna to answer them right now. And then it was interesting to see that still people, when they're talking about space architecture, people are actually separated into two groups. The majority of them. So people think that it's a burnosphere. The first image that comes to their mind is burnosphere or annealed cylinder, which kind of makes sense because it was really a very first concept of NASA to how you're going to live in space. And then O'Neill, he wrote a book about that, which is like just must read for all who is interested in space exploration and especially in space architecture. And there's a lot of useful points of how you can on the points of design. And then the International Space Station is just what we have right now. It's truly space architecture.
So in an effort to be respectful of everyone's time, maybe we can pick one or two questions from the Q&A and leave our contact information for anyone who might feel like they want to continue this discussion to follow up with us.
Sure, sounds great. So the first question to you guys is why the dominant color with the interior designs for space habitats seem to be white, while it's known for human emotions, well-being, green is the color that has the strongest positive effect. So Erin, how do you think about that?
So I think part of it is that utopianism, like our strong association with white being like clean and organized.
Yeah.
I think also like when you look at the ISS, there's a lot of white nomex on there, which does have like a functional application, but we don't need to show it everywhere. So I think I kind of addressed this a lot with the utopianism comments earlier, but I'd like to throw it over to maybe Melodie, who might have some more thoughts on it.
Yeah, I think that there's definitely a bias in science fiction and sort of depictions of future interior spaces as being extremely minimal, as being extremely kind of pristine and sort of having this kind of like medicinal quality that isn't super warm or welcoming, or that doesn't really acknowledge like green or the necessity of biophilia or color or any of some of these concepts that Anastasia touched on earlier. I think that in general, from a design perspective, white spaces tend to be perceived as larger and more expansive than dark spaces. That's just in terms of like color value. But generally speaking, I think that aesthetics has not really been the driving factor in much of the work that I've done, but absolutely from a psychological standpoint and from a kind of cognitive standpoint, to establish for principles of orientation in microgravity, absolutely differentiating surfaces through color and texture is going to be something really critical. And I don't really see a reason why we should subscribe to this idea of like the super minimal science fiction pristine white interior as being the only way to address space habitation.
Yeah, this was a really good question, because I always was wondering why it's always, the sterile white, and why not it could be, colorful or something like that, diversify our experience. Yeah, thank you so much for the answers. And then the next question is a limited supply of manufactured air. How do you have systems in place that would isolate and protect people in space in case of a virus? Would like to answer?
It's a great question. I think that my understanding is that multiple redundant systems that could potentially quarantine, cellularize, jeopardized areas will be essential within any kind of habitation system, so that if you do have like a lethal pathogen or something that gets in the way, that could compromise the mission, that could compromise human life, you absolutely need a way of addressing that structurally and in terms of your habitation system. So it's a great point. It's a great point to be making in the climate that we're currently in, and it's something that should be addressed for sure.
Yeah, that redundancy of systems, the proper filtration to help clean and provide and circulate the air, especially in our current situation where we're trying to isolate ourselves in our own biospheres. Being able to do that smartly in space, whether on a ship traveling or on a colony elsewhere, that compartmentalizing backup systems and that constant filtration of clean and healthy air is going to be important. I also noticed too, limited supply, and one of the most popular questions was talking about at the top, up to, it was voted up, nature as being huge. And of course, our nature provides us the oxygen and the air that we, breathe or partially resulting from that. And so, all of the concepts that we're looking at in that too, especially when you get to sci-fi, you see a lot of, you'll see a lot of green space within these environments. And I'm just curious, as you guys are looking at space design, if you're bringing nature into your designs as well.
Yeah, to play off that, I think one of the interesting architectural movements we've had on Earth is the mid-century modern movement, and especially a lot of what Frank Lloyd Wright did, bringing in nature, like mimicking nature in the spaces people occupy the most, their homes. And I don't think we've often seen designs, space architecture designs where there's wood or stone, and we can actually mimic these materials really well too, because like philosophically for me, we belong to Earth, and we need to be taking bits of Earth with us as we go into space. So like, what is the equivalent of the mid-century modern movement going to look like for space architecture? I think it's a very interesting provocation. And then to jump back over to speak about pathogens and viruses for a second, there are several concepts of operation for like long-term missions to Mars where we have multiple spaceships sent. And we think about, I think this is speaking towards a redundant system of having a place to shelter from not just viruses, but things happening to failing technology on long-term missions. I think Also, Star Trek has given us inspiration. There was a challenge for the Universal Tricorder project, the tricorder being the device that they use to diagnose medical conditions. And that is us directly taking a concept from a piece of sci-fi and using it to improve human health in space. So that's just like a few disparate thoughts dumped together about all that.
Great.
Yeah, thank you, audience, for asking this question. That it's really relevant to our time, and like as you see, that our life is so fragile, and this is like people asking me like in majority like who are space enthusiasts, and they're asking why we should explore space where there's a lot of problems on Earth, like the current virus we have right now. But like exploring, trying to reach the stars, it would be kind of a backup plan, like in a sort of sense. But first off, it's of course it's exploration, expanding our limitations, exploring our nature of humanity. And I like to quote Stephen Hawking that he said, I don't think the human race will survive the next thousands of years unless they spread into space. There are too many accidents that can befall life on a single planet. But I'm optimist. We will reach out the stars. And thank you again for asking these cool questions. If you don't mind that we would reply these questions maybe on our LinkedIn's profiles, that you can find links here. And I saw there's many questions to Melodie, to her designs. You also can address these questions to her email. You can see her email in this slide. So yeah, and thank you so much for being our audience today. We're really excited to promote, to think about how we're gonna live in space. And as we are all human being, we cannot be machines in a machine, right? You should make a change in this emerging field. We should have more people interested in this. We should have multidisciplinary teams. And yeah, reach out with any questions that you have. Yeah, you can see all the links on this website, slide. And thank you again for being our audience today. Do you think we might plan any other events anytime soon? Maybe in the end of April. I will announce it on my LinkedIn, so please stay in the loop.